In this video, I'm going to look at how to solve a system of linear equations using the TI-84 graphing calculator. I've done some with the TI-89. Here the focus will be on the 84. And we'll be looking at the scenario where we have same number of variables as we have equations. So in this case, we have two variables, x, y, two equations. You could have three variables, three equations, and so on. The procedure is going to be the same. Now, if you have more equations than you do variables, then you're going to have either a no solution or an infinite solution. In this particular case, we have three scenarios. Either you have one solution, which means, in our case, the lines intersect at one point. You have no solutions, the lines are parallel. Or you have an infinite solution, the lines coincide. Okay, and the calculator actually uses matrix operations, in particular row operations. So we want this to be set up as a matrix. So we want the x and the y on one side, the constants on the right, and then you set it up this way. So notice the first row has the coefficients here, 2, -3, and then 12. Second row, 7, 5, 11. So in other words, we're ignoring the variable for now. And basically the calculator puts your answer in this form right here. Okay, 1, 0, 0, 1. So this is if you're dealing with two variables, two equations. Here on the left of this bar, you have the 2 by 2 identity. If it's three equations, three variables, you have the 3 by 3 identity, and so forth. And then if everything is done correctly, then right here should be the value of x and y, because this reads 1x plus 0y is 3, or x is equal to 3. 0x plus 1y is -2, or y is -2. Okay, so this is the way it works then on the graphing calculator. We go to the matrix menu, so hit second, and then x to -1, xs is the blue icon there, matrix, hit enter. So there you have your matrices. So then you want to pick one of these matrices. It doesn't matter which one, you'll have to edit, define the dimension of the matrix, and then enter the components. And if it has components, you just re-enter the ones you have, and it'll delete the ones that are already in there. So go to edit, and this matrix, this augmented matrix has 2 rows, 3 columns, so we want the dimension to be 2 by 2. So 1 is already highlighted, so we hit enter. And then we want 2 rows, enter, 3 columns, enter, and then you enter the components. So this should be a 2, enter, -3, enter, 12, enter. Okay, and then 7, enter, 5, enter, and then 11. Okay, and then we get out of this menu, second quit. Again, go back to the matrix menu, second, then hit this right here to get matrix menu. Now here we go to math, and then scroll down to find the command we're going to use here, which is this one right here. The first one there, REF, is row echelon form. That gives you the partial solution. You have to do the work to get the answer in some cases. This one gives you the complete answer here. Reduced row echelon form. So hit enter on that one. And then you just put in here the matrix that you're using. Okay. That of course represents the system. So it's the second matrix. We said we used A for this one, so hit enter. And then hit enter again, and it'll solve the system. Okay, so there it is in this format here. So this reads 1x plus 0y is 3, or x is equal to 3. 0x plus 1y is -2, or y is equal to -2. Okay, so the answer to this one then, the value of x is 3. The value of y is -2. And you can easily check this by plugging it in there and getting the value on the right side. Now here we're just dealing with two variables, two equations, so these are pretty basic. But if you go and say solving a 3x3 or a 4x4, that is three variables or four variables, it gets a little bit more complicated. Okay, but that's the way it works here. Okay, so let's clear this. Go to the next one. Okay, so for number 2, again, same thing. Go second, and then access the matrix menu right here. And then we have to edit. I could use the first one again and just re-enter the component since it already has a dimension. Okay, but I'm going to go and use number 2 here, or B. And then again, this is again 2 rows, 2 columns, so this will be 2, enter, 3, and then enter the components corresponding to each equation. So this will be 9, enter, a -6, enter, 7, enter. And then for the second row, the values are going to be 3, enter, 12, enter, -7. Okay, and then we get out of this, second quit, and then I get to the math menu. So go matrix first, and then over to math, and I can scroll down to the same command. This one here, hit enter, and then go back to the matrix menu and select the matrix that we use. This was B. I'll put it a 2 then. There you have it. Close parentheses and enter. Okay, so 1, 0, 0, 1. Okay, so anytime you have that, the identity 1, 0, 0, 1, that tells you you're going to have one solution. Okay. And then the answer is going to be the values on the right. Okay, these are fractions, or decimals I should say. If you want these as a fraction, then go to math menu right here. First one is fraction, so hit enter. So now this answer will go to a fraction. So this is going to be, and there you have it. Again, 1, 0, this is supposed to be x is 1/3. 0, 1, that tells me y is -2/3. So the answer is 1/3 for x, -2/3 for the y. Okay? So again, x is 1/3 and y -2/3. Again, you can easily check these by plugging them in for the variables. You can write it as an ordered pair, depending on what your instructor wants you to do. You can write this as 1/3, -2/3, and you could put braces on that to put as a solution set. Okay, that's up to you or your instructor. Okay, let's clear all of this. Now, on the next one would be the same thing. Okay, so this would be, you can see it's already set up, 2 rows, 3 columns. So you would go select your matrix, so this would be second. Matrix menu. And again, you can select any one you want into the component, so it works the same way. Just to save some time, I already did that for this one. And I use matrix C, or number 3, on this one. So I'm going to go over to the math menu and scroll down. And this one again. And then go back to the matrix menu and select number 3, corresponding to this system. Close parentheses, hit enter. Okay, so notice on this one, on the the bar is not there for the calculator doesn't put the bar that I used, but anyway, you can see it's instead of 1, 0, 0, 1, you have 1, 2, 0, 0. So this would tell me that 1x plus 2y is equal to 0, and 0x plus 0y, which means 0 and 0 is 0. So this second row basically is indicating that 0 is equal to 1. 0 equal to 1. That cannot happen. So anytime you have this type of situation, that's going to be the case where you have no solution. Okay, so in this case, this is no solution. So that would mean that the lines, in this case, we're dealing with two variables, first degree variables, so still the lines are paralleled, don't intersect, so there is no solution. Now I want to point out to you that if you were dealing with, say, 3 variables, okay, 3 equations, and you came up with something like this, and all the components in, say, the last row were 0 except for the last one. Okay, so let's say you had 3 variables and you had 0, 0, 0, say 1, or 0, 0, 0, 2. That would be a contradiction because you'd have 0 equal to a non-zero value. No solution. Okay? So that's the second type of answer you could have. Clear this? Now, on number 4, again, same thing. We go to the matrix menu. And then, again, I used number 4 here. I already entered the components in the dimension, just 2 by 3. Okay, entered the 1, the -2, the 4, and the -8. Okay, so I'm just going to go to the math menu here and solve it. Scroll down to this one here. Okay, go to the matrix menu and select the one we use, which is D. So enter 4, hit enter. Okay, so notice on this one, instead of 1, 0, 0, 1, if this was 1, 0, 0, 1, that would mean x would be -2 and y would be 0. Okay, but because it's not, and in the last row is 0, 0, 0, this would say 0x plus 0y is equal to 0, or 0 equals to 0. That one is true. Okay, so what this is telling you is that there's an infinite solution set. Infinite solution set. So this would be the scenario where if you're dealing with lines, which we are in this case, the lines which coincide. So it would be many points of intersection, so infinite solution. Okay. If you have an infinite solution, you can write your answer in a formula format. Okay. So actually the answer to this one, what you do in the formula format is you express the answer in terms of one variable. Okay, so normally in this case you have 2 variables. You would have your answer this way. Okay, so in this case, if I let the first component be x, then the second component, if I solve the first equation for y, y would be -2. Minus x. So if I want to express this as a formula, this would then be -2 minus x. And this would be a representation. Now, you can say infinite solution, but sometimes your instructor might want you to write it as a formula, okay? So that means if you can select any number you want for x, so let's select, just to keep it simple, let's select x to be 0. 0 here. Second, the y then would be -2. And then that should work as a solution. And you can see it does. 0 there and a -2 there gives me -2 is equal to -2. 0 there for the x and a -2 here would give me -8 is equal to -8. Okay, so that's the way you would do it. A little bit more involved for 3 variables or 4 variables. But anyway, the calculator tells you the type of solution you're going to have. And if you have a unique solution, it's going to give it to you. Okay? So again, works the same. The setup is pretty much the same for 3 variables, 4 variables. You just have to define the order of the matrix and enter the components. Okay? Thanks for watching. We'll see you in the next video.